Oh, awesome. We have a couple more folks joining, but I think we can go ahead and get started here. Thank you all so much for being here with us this morning. We're excited to kick our 2026 Energy Code training series off with the 2025 Energy Code update class today. This training is going to be recorded, and you will receive a copy of the slides as well as the recording after the training. So we're excited to have you here. If you have been able to put your introduction in the chat, we'd love to know your role and your level of experience. And if you have any questions as we go, please do feel free to enter them in the chat. We've got Grant Murphy here monitoring the chat, or you can feel free to unmute yourself as well. We are a little bit larger of a group, but we love the interaction, so definitely encourage you to be an active participant. And before we dive into the meat of the training, I am going to do just a quick introduction. My name is Jess Blackwell, and I work on behalf of the Codes and Standards program at the Central California Rural REN. The Central California Rural REN, or what we like to call CCR REN, was approved back in September of 2024 with a budget of 36 million across our programs. One of our programs is Codes and Standards, which has brought us all here today. And the County of San Luis Obispo is the lead administrator for the CCR REN. They're responsible for coordinating all of us partners to implement programs. And we do have 6 programs designed to serve hard-to-reach customers and disadvantaged and underserved communities. And a little bit of background on who CCR REN is. My organization is High Sierra Energy Foundation. I'm based in the Eastern Sierra, which is a very beautiful place. If you haven't had the chance to come out here, I highly recommend it. And again, County of San Luis Obispo is the administrator for all of the CCR REN. And then we have partners in Monterey. That's the Association of Monterey Bay Area Governments. In the San Joaquin Valley with San Joaquin Valley Clean Energy Organization. And then the County of Ventura, which serves on an advisory role. And then I'm going to turn it over here to our partners for our Codes and Standards program, which is In Balance Green Consulting. And our trainer today is Jennifer Rennick and supported along with Grant Murphy. Thank you so much.
Thank you. Well, welcome everybody. In Balance Green Consulting is the name of the firm that Grant and I are a part of, and we've been contracted with CCR REN to provide the training. I'm a licensed architect and also a certified energy analyst, and Grant's also a certified energy analyst through Quebec. And we provide, a variety of services, including Title 24 Energy Code coach and Energy Code documentation. And we do training for the CCR REN. And we can just kind of FYI, we're available to do online training like we're doing now, but we also do in-person training and topics by request. We've helped other jurisdictions or a number of jurisdictions with some of their energy code compliance in Title 24 documentation, ADUs, and kind of materials to support that. Specifically for our energy code coach, it's available to plans examiners, architects, builders, project owners. It's free, and anyone in the CCR REN territories is welcome to use the service. There's a form that you fill out. It's easy. I'll show you a slide at the very end on what that looks like. Code coach, typically Grant or I, will respond in 1 to 2 days. And then we're happy to do phone follow-up when needed. Sometimes it's easier just to talk in person. Some of the common questions we get for Code Coach is, I'm looking at some of these questions and I'm thinking, last code cycle, we got a bunch of these questions. Now, Grant, what kind of questions are we getting now? I think it's mostly to do with heat pump water heaters is what I've been noticing.
A lot of heat pump water heaters, and then every time when we have a code cycle change, there's a lot of software questions. I get a lot of the Title 24 consultants and engineers saying, hey, something's not looking right or not spawning the way I usually see it, calking out. So we've got a flood of those right now. Yeah, but
And
this is a general list. The Cal Green, a lot of EV charging. Anything is a good question. Some are really complicated. Some of it's just an easy one, and you just need a double check. We're happy to help.
right. And sometimes it's just pointing someone in the building department that's like, okay, something's scratching at the back of their head. They know that there is this code issue and they can't seem to find it where they think they should be able to find it. So that's a great code coach question, because we can often just direct you to the part of the code where it is.
Yeah.
And sometimes, it's not in the energy code. They're remembering it from the residential code, but it's related to energy. We get those kind of questions too.
And I just want to jump in because I'm seeing that we have
Yeah.
looks like we have a good chunk of building department staffs, a bunch of plans examiners. Just bigger picture, this code coach, it's not a third-party plan check. We won't do your plan check comments, and we can't do compliance documentation in 99% of the cases for everyone. So I can't just don't just send us a whole plan set and say, hey, tell me what's wrong with it. But I often get on a Zoom call and walk through the report and the project with you, and we can chat about it. So trying to be educational and assistive, not, hey, you guys have your contracts for your third-party plan check, guys.
Yeah. Okay. Good point. And okay, I see we have a variety of experience too. Thanks for everyone who put that in the chat. Some folks with a number of years and others new to the code. Okay, I'm going to try and hit like high, middle, low, sort of like folks who've had, a lot of experience, medium experience, and maybe are new to the code. So hopefully there's something for everybody here. You do get learning units for this. So if you're licensed architect, you need AIA learning units, you get 1.5. And if you are needing ICC units, you get your 0.15 for that. And then slides will be provided to everyone who attends. So today, I'm going to give you a little bit of background on the energy code, kind of in general, sort of some context for the folks who are new to the code, and then a little bit about how the energy code is organized. So help you know where to find things. Again, maybe that's maybe a little bit more applicable to the new folks. And then some new terms, metrics, definitions that are new to the 2025 code. And then I've kind of picked my favorite, if you can call it favorite, topics that I think kind of stood out as what's different for 2025. And I've kind of hit on that with kind of the all occupancy types, and like spoiler alert, it's heat pump water heaters. And then some highlights for non-res, single family, and multifamily. There's a lot of nuanced changes. I won't have, in an hour and a half, we don't have time to go through all 700 pages of the energy code, but we'll hit on a few of the things that I think are most applicable for us and give us a background for it. Okay. For those of you who are new to the kind of energy code and the process of the energy code, California Energy Commission updates the energy code every 3 years, along with the other parts of Title 24 that make up California's building standards. And then the title, what we call Title 24, Part 6, is the energy efficiency building standards, and often just called the energy code. And that process is in California for the energy code, specifically for Part 6 of Title 24. It's a multi-year process, and the adoption timeline for the energy code for the one that just took effect January 1st, 2026. We started this process back in 2022. And I say we because California Energy Commission involves, a broad base of stakeholders and interested parties in the public to participate in the data gathering and kind of the pre-rulemaking process. And, last August 2025 through all the way through July 2026 coming up. This whole year is part of the data gathering process for the code that would take effect January 1st, 2029. That would be the 2028 energy code. Now, kind of put a pin in that because I think most people are getting the word, but maybe not everybody yet. AB 130 put a pause on parts of the 2028 code cycle. So in other words, the residential standards that came into effect now are going to stay in effect until 6 years from now instead of 3 years from now. So they're going to be in effect until 2031. There's some kind of debate on whether or not there's going to be allowed some code update that just clarifies existing code language to make it easier, but not change the code. So kind of a interesting process we're in right now. And then it only applies to the residential standards, which could include your multifamily projects. And there are some things to take note, some exceptions. For example, if the state fire marshal has amendments, those would go into place. And it also precludes local jurisdictions from having new REACH codes. So if a local amendment went into effect or was put in place in September of 2025, that will still stay, but there's no new REACH codes for a while. Now, for those that are kind of new to the energy code, I put this slide in here just to remind folks that the energy code, so Title 24, Part 6, it covers everything that we call building envelope, and that has to do with your floors, walls, windows, roof, insulation levels, air sealing, everything to do with kind of the heat transfer through those assemblies, and then other entities that use use energy, such as your hot water, heating, space, heating, cooling, fresh outside air ventilation, your lighting, and then solar energy, battery systems, and also some covered processes such as refrigerated warehouses, controlled environmental horticulture, elevators, and a few other process loads. But what's not covered in the energy code would be your household appliances. That would be under Title 20. And then the small scale residential heating and cooling systems, also Title 20, along with the walk-in coolers, freezers. And then, kind of out in our CCR REN territory, we have a lot of projects that aren't really covered on the energy code because it would be agricultural barns or warehouses other than covered process loads, or refrigerated warehouses under 3,000 square feet, and temporary structures. Those are in a different category. But everything else is pretty much covered under Title 24, Part 6 Energy Code. Now, California currently gets a lot of its energy from non-fossil fuels, but we still get a lot of our electrical energy from natural gas powered natural gas fired power plants. And the reason I am mentioning this is it's kind of the setup that California, Part 6, Title 24, and California as a whole, we're moving more and more towards all electric buildings. The buildings don't have to be all electric, but we're kind of moving towards buildings more and more being electric. And the reason that is a good thing for California is heavily invested in setting up more renewable resources like wind and solar power and having battery systems and battery backup. And part of that whole utility mix is when, there's certain times of the day and certain times of the year where solar, wind, and battery may not be enough. And so that's when we have natural gas peaker plants that kick in. So we do have peaker plants spread out throughout California. This is an example of one located in King City, and these will fire and burn natural gas to create electricity, and typically during the 4 to 9 p.m. hours, time of the day, and then a little bit throughout the night, and then really not needed during the middle of the day when the sun is shining bright in California. And so
the reason we include all of this is because the reality, as Jennifer mentioned, is just the state's code, the energy code, regardless of our opinions about the nuance of everything within it. They're going to continue to push electric appliances, all electric construction. And on the other side, not part of our work that we're dealing with, there's a whole nother industry of people trying to provide cleaner grid energy. These two things work not at the same, not together, but hopefully at the same time. This question comes up to me all the time, like, hey, why do I have to do all this stuff if the grid's not clean, right? We don't have control over that, and we know that California's goal, this 2025 code, the 2028 code, it's just going to get harder to fight this. So that's when a lot of our conversations are just like, we got to get behind it because the code is going to make this prohibitive to us.
That's right. Yeah. And then, just like a segue, perfect. Just as Grant was saying, as we bring more and more what's being coined as clean energy systems to the grid, i.e. renewables like hydroelectric, like long-term battery storage, like solar energy, wind energy, then we won't need to burn fossil fuels as much to create our electric energy. So then overall, we have a lot less air pollution in California. And for any of you who've ever lived in and around some of the inland valleys or Los Angeles area, and if you're my age, and I saw a couple of folks that they've been doing this work for a while, you probably have seen how the air quality has vastly improved in some of those areas. And a lot of that, yes, cars, but also in a lot of those jurisdictions, some of the big power plants have been decommissioned, the ones that burned a lot of fossil fuel and are coal plants. We don't rely on coal in California anymore. So big picture for the energy code is all of these standards that have been put in place since the late 1970s, around 1978 was the first code. It has saved our state billions of dollars in not needing to build new expensive power plants and polluting power plants. And then the 2025 standards that just went into effect are estimated to provide $4.8 billion in statewide energy savings. So part of how the energy code is doing this, which is what Grant was just touching on, is the energy code's encouraging electric heat pump technology for space heating, space cooling, water heating, and we're expanding our PV systems and battery storage. And there's also a synergy between some of the code updates in the non-res standards, which we won't go into much detail. It's really kind of from, I think, your mechanical engineers to really grapple with. because there are efficiency standards on the equipment that need to be met. But some of those efficiencies have to do with how much water those like chillers are using, thereby reducing or water use, which helps California, and saving energy. So there's a synergy there for both of those. Okay, anything, Grant, you want to add on to that?
No, that's great. I think we got to get into the code stuff, what everyone's here to
Yeah.
hear about.
Okay. For those of you, again, trying to kind of hit high, middle, low for where people are at. If you're new to the code, you might not realize that California has 16 microclimates or 16 climate zones. And the California Energy Code, as we kind of look through some of these things, it's all based on your requirement for your climate zone. And if you're not familiar with it, the CEC has an online tool called the Easy Building Climate Zone Finder. And I put the website there, which is a nice tool, pulls up a map like the one on the left, and then you can locate your property and figure out exactly what climate zone you're in. For our CCR REN territory, we've got, the Central Coast region, our San Joaquin Valley region, and our Eastern Sierra region. And then all those three together make up our CCR REN territory. And when we kind of overlay that with California's 16 climate zones, we really have a variety of climate zones. So our Central Coast is, mostly climate zones 3, 4, and 5, San Joaquin Valley 12, 13, 14, and 16, and then the Eastern Sierra is 14 and 16. And so those climate zones are going to dictate kind of which part of the code is applicable. And then, so kind of put a pin in that. You've got these different codes. And then the California Energy Code, they kind of look at, all of these buildings based on their occupancy. And so there's some mandatory measures, things that all projects have to comply with that are across all occupancies. And that's kind of up high in the building tree. I mapped out, for those of us who are visual people, I kind of mapped out how the energy code is structured. And then we have these three big buckets where we start out with, kind of in the middle of the code, we've got single family residences. And then now, or as of last code cycle, we have the multifamily residential sections. And then the not residential sections, hotel, motel, other non-res, covered processes, etc. And then that codes and standards, about 700 pages worth of material. It has another book that goes with it, the reference appendices. And those reference appendices, you really, if you're getting into the energy code, you need both of those books together, because the standards constantly are referring to, oh, here's this code requirement, and you need to do it per, it'll say JA and then some numbers after it, or RA, some numbers after it. That's all referring back to those reference appendices. And then for those of you who want to really learn a lot more about the energy code itself, there's 3 compliance manuals to help you understand like common questions and kind of common things that come up with the energy codes. So they have a manual for your non-res, multifamily, single family. And then there's 2 more manuals that specifically talk about the what's called alternative calculation method, or ACM. And that is for the computer calculations that run in the background when you do a computer or performance method of showing compliance with the energy code. And then new to all this is the data registry manuals. And we'll kind of touch a little bit more on that data registry in the sense that it is for residential projects that have to be registered on a statewide database. If you're new to the code, that may sound crazy. If you've been doing the code stuff for a while, it's just the book that Cheers has to read and follow.
Yeah, that is our cheers these days. It used to be CalCerts. CalCerts, I don't know, disappeared. So now that is Cheers for all single family. And we'll put in a link in future ones. Maybe we can do a little slip sheet with the link when we send out the slides. I use Energy Code Ace. Energy Code Ace is a CPUC funded program. I'm sure a lot of people are familiar with their resources. We refer a lot of our customers to their resources. They have a online reference ACE that is a searchable, free in your browser version of the code books, the manual. So if you don't have the physical book copies, if you don't have an upcode subscription or a PDF copy, that's a great place to become familiar with chasing your answers.
Yeah, that's right. And also just point out, because even some folks who've been doing the energy code stuff for a while, you might not realize that there's a table called Table 100-A, and it's the application of the standards. And they each kind of code cycle, they expand this a bit more. So you look at it, left to right, kind of the occupancy type is the first column, then your application. If it's a mandatory measure, kind of put a pin in that term. Prescriptive, put a pin in that term. Performance, that's your computer energy model. And the additions and alterations. Okay, fairly straightforward, but it goes on for a while. And so new to this code cycle, they've added some demand response controls in the table. So it makes it easier to look up if you know you're going to work on that. The table's very helpful. It is also, like Grant said, if you do search with Energy Code Ace, you can do a search and get to the same place. But if you're using the ICC published books or this California Energy Commission published books, these tables are super useful. And then it does the same thing for the single family and
some of these
idea
slides
for
we leave.
multifamily.
Some of these slides we put in here for your guys' reference later, just because we get questions after saying, hey, where was that table? So when you guys look back at the slides, we just lump them all in.
Yeah, that's right. That's right. Exactly. Okay. New terms, metrics, definitions. So mandatory measures, those, then I said to put a pin in it, that was refers to energy efficient measures that are applicable to all projects. The prescriptive component package, so that prescriptive column, it follows like a recipe card. It's essentially a checklist. So your building will comply with the prescriptive component package or the prescriptive method if your building follows every single thing in the checklist. We don't see a lot of projects go this route necessarily. A lot of times the projects we're working on, the architect and the design team want what's called trade-offs. So they want us to do a computer energy model and do a performance method where that prescriptive component package becomes the baseline. And then we do a proposed building that matches the architects or the design team's project. And then those two things are compared. And if the building passes several metrics in this computer method, then your project meets Part 6, Title 24. So new to the code this year, we have now a metric called long-term system cost. And it for non-res projects, it used to be TDV, but now, and for residential, it was EDR, but now it's just going to be long-term system costs. And there's an efficiency part of it, which doesn't include your PV battery. And then there's the total, which includes your PV battery contribution. And there's also, like the last time, there is a source metric. And similarly, the source metric kind of represents the annual impact on the carbon emissions for the creation and delivery of that energy used. So this is where, depending on your climate zone, what territory you're in, you can have a slightly different impact on these scores because of where and how the electricity is generated. And if all three of those pass, then the project passes. And then there's a huge report that goes with it. And today we don't have time to go through the whole report.
And Jennifer, real quick, I just want to jump in. So that source energy is most often the, hey, why can't I do gas? Why can't I put a gas water heater in my project? I'm passing the first two for your building. It appears fine. And then as you add in that where the energy was generated proxy, that's where they're giving us the penalty. So a lot of people go, I'll get a call, hey, this thing just can't pass. I can't get this source thing to change. Nothing's moving my metric. They throw in a heat pump water heater, it passes all of a sudden. That's where they're kind of getting you forced. And then, real quick, Jennifer, I just want to, can you go back one slide?
Yeah.
I think
Was it
to
which
the
one?
mandatory prescriptive performance.
Yeah.
So my quick little take on it is, so your mandatory requirements is like the legal minimum of building. That doesn't mean you can just do those. It means you have to do those. And then the prescriptive package, Jennifer said we don't see it often. The times we do see it is for a lot of alterations, commercial alterations, and it's a specific, hey, we're doing an HVAC swap out. If you are doing a not residential, a non-res project, those TurboTax, and when you do the forms, it looks like TurboTax. Those are on energy codings. If you're doing residential prescriptive forms, it's still a TurboTax looking thing, and it is in Cheers. So that's like you're not using an alternative software. You're just going to your browser, filling it out, doing exactly what the code says you want to do, and then you pass. Part of that is, hey, prescriptively, your wall needs rigid insulation. Well, my contractor doesn't want rigid insulation. Now we're going into the performance method and we're not doing rigid. We're taking a penalty on the walls, but hey, we put in better windows. Now it passes. So that's just kind of the two processes and why a lot of project teams pick one or the other. All right, you can go back, Jennifer.
Yeah, perfect. I'm so glad you said that. That's right. Exactly, with where to find those forms also. The other kind of big, again, we're kind of doing these big picture things for our multifamily projects and our residential projects. For a while now, we've had HERS raters come out and verify certain measures, and in that performance method, you could get extra credit, and sometimes you would need a HERS measures just as part of the mandatory requirements, like verifying kitchen hood fans or the exhaust fans in the bathrooms meet certain capacities. Sometimes refrigerant charge is required as well. So your HERS rater could come out and look over the shoulder of the, in residential project and make sure that the guy doing the refrigerant charge on the air conditioning unit was charged properly, paperwork signed. They deal all that through Cheers, through that data registry. Now the new code has said, hey, we're not going to call it HERS anymore. We're going to call it ECC for Energy Code Compliance. So under the kind of the old code, all of the HERS things was under Title 20. Same place with the small appliance standards. And the HERS rater did the field verification and diagnostic testing. Okay, now under the new 2025 code. We've got the ECC program, so the Energy Code Compliance Program, and we've got the Energy Code Compliance Rater. Still continues to do field verification and diagnostic testing, but now all of it's been pulled into Title 24. And this includes a quality insurance program. So the rater can needs to participate in a program where they'll go out with the provider, cheers, and see that they're doing their work properly. So kind of that's sort of a big picture. We'll hit on it a little bit more when we get into the other sections.
And so for the HERS change, it's really for everyone. It's really all they did is change the name. There's no changes to the requirements themselves. They just changed the name of those individuals in the program. And then we're hoping that the switch from having that code section in Title 20 to being located within Title 24 is going to clarify a lot and make it ease of finding these requirements, better training those verifiers, and then that QA is something that we're hoping improves a lot of the labor force. We'll see.
Yes, that's right. And big picture again, a couple big pictures is just FYI, laboratory as an occupancy now has been included within the Title 24 Part 6 Energy Code, as opposed to only being mentioned in the building part of the, building standards like Part 2. So because of that, there's some expanded definitions, etc. And so you can expect to see some of this show up in the reporting. Also, kind of big picture is a number of definitions have been added. Again, this is that high level of the building tree, section 100.1. And I'm calling out specifically the water heater section for new definitions because these words are used quite a bit now in talking about the water heaters and some of the mandatory measures and the prescriptive and just, being able to speak the same language with everybody. So there's a lot of different type of heat pump water heaters out there. Integrated is this type here where the heat pump and the tank are all integrated into one appliance. And that's typically for small commercial and residential projects. And then the split systems, you can have either a split refrigerant or split hydronic. And I'll show you a picture of those. Just means there's an outdoor unit and the tank or the heat pump and the tank are separate. And then kind of independent of that, each of those systems can have what's called a multi-pass water heater or single pass water heater. And that just means how many times the cold water passes through the heater before it's put into the storage tank. So here's an example of what a split refrigerant system could look like. This was from a project that we worked on last year, and happens to use Colmac brand, and these are pictures during the installation. But the heat pumps are located outdoors, in this case up on a roof, and then the tanks were located indoors, and then the refrigerant line that connects these outdoor condenser compressor units, it's going to be heavily insulated, and there's storage tanks located inside, a little bit insulated like that picture shown down at the bottom. And you can get low global warming refrigerants for it now. And then there's special kits you can order it so it gets down to like 23 degrees Fahrenheit. So I mentioned the range because there's certain products you need to look into, and your mechanical engineer if you're doing a big project, you'll have a mechanical engineer. They'll be up on it because you can't use all products in all of the climate zones if you're dealing with freezing, for example. Or you have to have a special kit for it. And then the split hydronic system, this example here is from a really mild climate. So even though we've got the outdoor condensers outside, the climate zone is mild enough that we can have our first level of storage tank also outside. And then we've got swing tanks, bigger tanks inside. But these Sandin or Sanco 2 units, they can go down to minus 26°F. So they can handle quite a bit colder climate, and they use CO2 as the refrigerant. So that's another bonus. The other definition in a slightly different section of that code, not under the water heater section, but air to water heat pump, you might start to see some of these. Sometimes they're referred to as a monoblock, and they can use the heat pump. Outdoor unit can heat your space, cool your space, but also heat your water. It could do any one of those things or all of it together. We haven't seen too many of these being installed in our area, but I suspect that it'll happen.
Yeah, there's a lot more of them coming to market. They're not typical yet, but the code's
Right.
getting ahead of it and including it, so we can start to use them and model them.
Yeah. And that's why I include it. Just kind of an FYI, it's coming on the horizon, and the code mentions it, and that's what it's referring to. So all occupancy mandatory measures, there's just a few things to kind of highlight here. So section 110.2, section 110.3, section 110.4, on your space conditioning equipment. If you're a mechanical engineer, take a look at this section because there's some new tables for your heat pumps and heat recovery chillers, and they've updated your cooling tower requirements, and some appliance tables have been moved, etc. Then the service water heating, specifically the installation of heat pump water heaters, the integrated type is what I'm going to focus on, but I wanted to give you a heads up that also on your pool and spa systems equipment, the sizing and the efficiencies have some new language, and there's some new language about supplementary heaters with the cutoff and cut on controls. And we're just going to kind of dive into these service water heaters, just the heat pump water heaters themselves. So a little sidebar, I threw this slide in here because we've been getting a number of questions now that lead me to understand that not everyone really knows what a heat pump is or a heat pump water heater. And so trying to think of a good way to explain it to folks. So this might be useful for your clients or just, folks at the counter. This picture on the left, this is from the back of the pickup truck of one of the guys in the field. He does our HERS rating. He's got a cooler traveler fridge. Bunch of folks have this when they go out hunting, blah, blah, blah. That they don't realize you've got a compressor condenser. You've got a little heat pump right there, and it's got ventilation openings. And you go to your heat pump water heater, and up at the top of the tank for the integrated type, you have your compressor, condenser, and ventilation openings. Okay. And then for your cooler traveler fridge, heat's removed from the air inside the cooler, and then that heat is taken out of that inside air, and it's kind of rejected to the surroundings. And just like a heat pump water heater, you have the heat removed from the air inside your garage, for example, your closet. And then that heat is, again, transferred or rejected into the water, and then we get hot water. So typically we would run through a bunch of design considerations for the heat pump water heater. And the reason, we talk about these design considerations is because they basically weren't really being followed that much. And as a result, the new Title 24 Part 6 Energy Code has now made a lot of these kind of design considerations a mandatory measure.
Can I jump in, Jennifer?
Yeah, totally.
So this has been the biggest pain of the previous code cycle and the heat pump water heater craze right now. When these things came on the market, they were fairly new. They had existed, but the amount of them being purchased and installed was dramatic, and code was forcing people into this situation. The initial ones that came out, you can see that last bullet. It said 750 to 1,000 cubic feet of volume. That was the original spec on a lot of those units. And if the system didn't have that type of air volume to pull from, they still have a electric resistance water heater in backup within this. So as soon as that unit didn't recognize that it had the airflow to operate in heat pump mode, it would just kick into electric resistance mode. So a lot of homeowners, installers immediately had a bad reputation surrounding these units because they weren't cheap. And when you install them, they said, hey, my electricity bill went up. These things aren't, they're not working well. And what we found is that the vast majority of them are just not installed correctly. Since that, 4 years ago, they've come down in the amount of volume required. You can see what did Jennifer throw in, 450. So it depends on the specific make and model of the unit, what that volume required is. They've come out with more duct kits, so you'll see more duct installations. We get a lot of questions on how to duct them, where the intake and exhaust. Can I just duct the exhaust? Can I just duct the intake? A lot of nuance, especially for a single family residence, where we're often replacing a tank unit. And it's trying to throw one of these things into the existing space of a gas tank unit that didn't require that volume. The code had the previous code, 2022, had a little bit of language, not a lot. Some very general guidelines that were often being ignored or not feasible. The remodel would require a substantial change to the space or relocating the unit. Small ADUs that already have a tiny footprint were being told, hey, you still got to use this thing. Well, where do we put it? We're seeing those little sheds built on the side of homes, et cetera, et cetera. This section that Jennifer's going to go through that just came out in the new code, it's mandatory requirements for these units, really details everything needed to have a correctly operational heat pump water heater. So you're going to see a lot of repeats of this code section in future trainings, in newsletters, in blogs, in you name it, reiterated to everyone because this has kind of been the big sticking point. So we're hoping that this section alleviates a lot of stuff.
Right. And then I kind of shortened it for this slide deck. And I didn't give you the whole code language. So I'm just going to hit kind of the highlights of this. But, one thing to keep in mind too is these units do have a operating temperature range, and you get below it and it puts you into that electric resistance mode. The main takeaway though is you got to follow the minimum volume per the manufacturer, or you at least need to take that minimum volume or at least you need to take the compressor capacity and multiply it times 100 cubic feet and you get a minimum volume. So that's kind of like that 450 because the compressor was maybe a 4.5 kBTU. permanent openings adjoining the space allowable. So then there's a net free area calculation that needs to go with it, also based on the compressor capacity or the manufacturer's specifications. And so where this kind of comes into play is that a lot of the stuff, it's really the plans examiner's kind of wheelhouse, because these aren't necessarily requiring HERS or ECC, but somebody somewhere, the designer, the mechanical engineer, should design the space properly. But at least you have a place now to go to in the code to take a look at it. And a lot of, just kind of rule of thumb, a lot of the compressors are 4.2 kBTU hour, and some of them are like a 4.5 kBTU hour. And then what that translates into is you know, for one of these heat pumps, you might need a room that's 7 feet by 8 feet with an 8-foot ceiling. And if you don't quite have that, but you have a pretty generous closet, you can then calculate a net free area for like a fully louvered door and have, you know, that calculation and have it communicate with the larger space. So then overall, you would meet that code requirement for the volume of space needed. And then if you go with a ducted situation, the code says, hey, you can use ducts to connect to another space. And then same idea, now your ducts are open to that other space. So you can, you know, they could be connected to the outdoors. So then you have a vast volume of air to work with, or they could be connected to a different part of your house, and that could be included as the volume. And then the new requirement is if the ducts do cross that pressure boundary, they need to be sealed and have R6 insulation. The other thing we're seeing, though, is not designing a closet or a space large enough. So this gives you an example, like a garage location passes lots of air, the pipes are insulated. That's like a good install there on the left. And then on the right, this is from a job one of our HERS raters was at. And there was an alcove designed and a closet designed just off of the garage, but the closet itself didn't meet the minimum code requirements for the volume needed. And then the door was solid, no permanent louvers or opening. And also just the space itself is so tight that that exhaust port is really too close to the wall. And so what'll happen in a lot of climate zones, even in a relatively dry climate, it's still enough moisture in the air when that wall gets really cold from that exhaust air that you can get some condensation issues. So that's kind of what we're seeing to really look out for, is just give yourself enough space. There's a resource here with energy.ca.gov. There's a blueprint. You can download those. I just excerpt it here for you just to give you an idea of also what that looks like when you're calculating your communicating spaces and the net free area together. So I thought that was a great illustration. For the moving on, that's, you know, and also keep in mind the heat pump, water heater stuff, there's more to it than that, but you're going to find it in the high level part of the building tree, not under those, you know, buckets of non-residential, single family and multifamily residential, even though each of these other sections refers back to those mandatory measures for the heat pump water heaters.
Hey, Jennifer, we had two questions I wanted to get answered real quick. Dale referenced section 150, allowing new dwelling ADUs to install a 120 volt heat pump in place of a 240. Are you going to go into the electric ready requirements in this presentation?
Briefly. But yes, that's true. And with a 500 square foot or less, sometimes we're finding for certain climate zones, the heat pump water heaters, like we just showed, might not be the best option. It just depends. So for 500 square feet or less, you could do performance method or use one of the exemptions for like a point of use electric, a little 20-gallon electric, water heater, and put it, within just a few feet of your shower. You can take that, you could go
Right.
that
So
route.
that one, if you're 500 square feet or less, you can use an electric resistance tank unit or tankless unit, I believe. And the only other requirement
And a
they
small
tack
one,
on,
point of
yeah,
use, small point of use.
yeah, what they tack onto it is the ECC, previously HERS, point of use verification. So in design, you should be showing that the water heater is located within the proximity to meet that point of use code section, and then it gets verified in field.
Well,
Um,
but that's now actually it's a plans examiner, so it's really your jurisdiction that's going to verify it, not the ECC.
oh,
So
good
yeah, so we're
clarification.
saying
Thank
to
you.
all the architects and plans examiners, you should take a look at that and have them, the designer, put on their drawing that they did that measurement to meet the point of use, because it also has to do with your piping size. So depending on if it's 1/2 inch, 3/8 inch diameter piping, it's also going to dictate the distance. We won't get into it in this particular slide deck because we were just trying to hit a whole bunch of topics, but it's in there, and we'd be happy to work with you on Code Coach question for that, for
And
sure.
then the second question, which I'll just reference and answer so we can keep moving.
Yeah.
Nick Holt brought up a real issue that we've been finding too. People run into this. He referenced a high altitude heating dominated, so it's a cold climate. They're primarily heating the spaces, that he's seeing additional heat when you're doing your load calcs and sizing for HVAC systems, that there's
Yep.
additional heat required because those heat pump water heaters, you're heating the water, the unit's dumping cold air into the space. Depending on where that unit is located and where that exhaust air is going, there's additional cooling being added to your home. And if your home wants heat, your HVAC system, your engineer, your contractor, whoever it might have been, didn't factor in that additional cooling being introduced, and you have to upsize and account for it. So he's seeing a lot of remodel installations are freezing. We've seen that too. It's an item that we're going to touch on again and more often. It goes back
Yes,
to
because
why these installations are so important.
right. So the next class we're doing with CCR REN, I think the very next one next month is going to be heat pumps in cold climates. And we're going to talk about some of this stuff because there are certain other things that we don't have time to go into, but okay, join us for the next class. We're going to hit on
Thanks,
that.
Jennifer. Keep going.
Okay, so big picture, high level on residential. Just FYI, your mechanical engineer, if you've got any on the call, there's a slightly different calculation for the outside air needed. And they've added animal veterinary occupancy types for all your required exhaust. And some lighting control updates. We don't have time to go into that. It's kind of nuanced, but we'll hit real quick on electric readiness for commercial kitchens. And I will give you a bit of an update on the walls for your envelope and for PV and battery. Basically for now, commercial kitchens, and again, commercial kitchens, quick service commercial kitchens, institutional commercial kitchens, they've also been defined. And bottom line is you can install gas cooking appliances, but if you do install the gas cooking appliance, then you need to make it electric ready, which includes a 50 amp minimum circuit that's easy to get to, and your capacity on the service panel's going to be 800 amps minimum. So just kind of FYI, if you're already doing induction cooking, it's electric kitchen already, then this doesn't apply. They would just size the loads. Your electrical engineer would size the loads to meet your appliance requirements. There's been some minor updates on our wall assemblies, and that does impact a bunch of the climate zones that are in the CCR REN. There really hasn't been much change on the mandatory minimum and hotel motels, but the wall insulation's improved just a little bit. And every line that's been crossed out is what it was. The line underneath is the new. This is straight out of kind of the code when I thought this was a nice way just to show you what has changed and what hasn't changed. The change isn't very significant, but just as example, if you take a wood framed wall prescriptively and you take a look at the table across the top, the CZ stands for climate zone. In our area, we've got climate zone 3, and we've got a U factor, and the U factor is kind of a measurement of the thermal heat transfer through an assembly. And the smaller, the better. Climate zone 5, that's our requirement, 0.095. Then climate zone 4, 0.053. And then it turns out climate zone 12, 13, 14, 16 all have this 0.053 U factor. But what does that mean? How do you translate it? That's where these reference appendice books come into play, because it'll give you the U factor, but now you have to go look up what that U factor means. So under the previous code cycle, if you had an R11 2x4 wall, you would meet the requirement for the climate zone 3, and then R13 2x4 wall, climate zone 5. But now, it's the U factor's gone down slightly. So now the R11's turned to an R13, where you used to be using R13, it's now an R15. Not a big deal for the mild climates in the coastal part of our CCR REN territory. But for all the rest of our territory, it used to be an R21 insulation and a 2x6 wall met, with an R2 continuous. So going back to that other diagram showing the continuous insulation. And now the update is that still a R21 2x6 wall, for example, the new requirement 0.053 is smaller than 0.050 is still smaller than 0.053. And now you need an R4 insulation to meet that requirement. So it only went up a little bit. And that's kind of the whole chart. It just only went up by an R2 basically on almost all the walls and on some of our roofs and ceilings. So not a big change, but it's good to note. For solar PV and battery energy storage, the size requirements have changed, and there's some updates on the occupancy types, and it is by climate zone. And the battery requirement really depends on your solar PV system size. The formulas have changed. And then to understand more about what's changed for like clearances, spacing, and the battery capacity limits, you're going to have to go to Title 24, Part 2.5 for the residential and multifamily, but Part 9, Chapter 12 for the non-res. And this is just an example of where some of these requirements as an architect or plans examiner are just split across codes. And so you'll have to reference both, or let your third-party plans examiner deal with it. Kind of the big update on the non-res side is that some of these occupancy types have increased their amount of solar PV a lot. And one of those examples is restaurants. And just to kind of give you an idea for the architects on the call, if you go to section 140.10, there's equation you follow. It's based on conditioned floor area. There's times A, which is a factor for your PV. So you divide that by 1,000. It's also based on your square footage of your solar accessible roof area. And then if your PV system size is very small, you don't have to install the PV. So there's some exceptions you should read. And again, I put this in here as an example. It's got some math in there, and we are happy for any of the architects on the call who want to get a rough idea of how much PV they need for a project. We're happy to kind of point you through this or help you sort it out. It's helpful sometimes to do this ahead of time because you may not have your PV consultant, battery consultant, or electrical engineer on board yet, and you're in schematics. But how you do it for a mixed project, for example, Climate Zone 13, maybe you have restaurant, some retail space, office, and lease. You do that formula for each occupancy types. And the factor A is on the table I'll show you next. And so you might calculate that you need 57.3 kilowatt system. Okay, or for a flat roof, 14 watts times your available solar roof area, 63 kW. You go with the smaller size, but now how do you translate that into something useful for an architect? Just kind of a rule of thumb I often give is like if you have a typical commercial panel now is about 480 watts per panel. So if you take the amount of kW wattage that you need, that kilowatts, you can divide it by your panel size. And in this example, you need about 120 panels. And then, you could figure out approximately how much free roof area or free canopy area you're going to need for your project. So approximately 3,080 square feet for that kind of mixed use project. Again, we're happy to help you with math. And then this table is in the code. So you'd look it up by Climate Zone 13, and you'd look at restaurants and the factor A that's required, the retail and its factor, and your office unleased space category and its factor. And those were the numbers I used in the previous formula. For the batteries, the formulas are a little more intense in the sense of a lot of times what I'm seeing is architects, designers aren't really using the battery formulas because at that point, they're working with their energy consultant or they're getting a PV battery consultant on board to really help them sort it out. But they just I want the architects to understand that some of these bigger projects have commercial batteries that can be quite large, but also it's also possible that you're going to use the performance method on a project. We had a big multifamily project lately, 2 of them, where they just traded off the battery component because the batteries were so expensive. So we're finding that it's good to understand that this is like the size of some of these commercial batteries, but you may you're going to need some extra consulting help is where I'm going with this. And part of the 2025 code update too, again, you're going to find this in Title 24, Part 6, Chapter 11, but there's the construction documents that are required for the battery system. And this is why I'm saying we're not going to go through the formula today because you're going to end up needing a battery consultant to do this, because you're going to need to have all of this on your construction documents. And what they added now for the 2025 code is a fire safety and evacuation plan that's required. For now, moving right along, for single family, there's an EDR metrics replaced. We kind of hit on that before. Their prescriptive requirements have been expanded for a number of things, for the heat pumps, for roof insulation, windows, ventilation, etc. And then really similar for the home battery stuff, you're going to refer to part 2.5 of the residential code for some of those other requirements. I put this slide together just to kind of give you a comparison of maybe what you were used to under the 2022 code cycle, the EDR metric now being replaced by the long-term system costs metric. And additions, alterations also move to that metric and away from TDB. There's some new prescriptive requirements that apply to all the climate zones. And this is what Grant was saying, where we're really just moving towards all electric. And so you can use gas appliances. It's just that they're no longer part of the prescriptive approach. And if you want to use gas appliances, you must use the performance approach. For some of the roof assemblies, FYI, all the climate zones now have kind of a boost in R value for an unvented cathedral. So R38 across the climate zones. And then R38 got a bit of a boost for climate zones 8, 9, and 10, which aren't really in our region, but just FYI, not much has changed for like a typical attic with ducts in the attic. For the windows, kind of the big deal for just about all our climate zones in the CCR REN territory, the U factor now is 0.27. So it's dropped, which means the windows have to insulate better. And that seems pretty straightforward, because a lot of window manufacturers are making windows that easily meet that. But the part of the code that's a little bit different is there's an explicit exception for projects that are in WUI or wildland urban interface, high fire hazard severity zones. And the reason there's an exception is because we have that mandatory measure, like Grant was saying, meaning that's like you have to do it. It's doesn't mean you can do your whole project this way, but at the very, very minimum, you would have to have a U factor of a 0.4. But a lot of windows, if they're fire rated, they're going to have a much bigger U factor, meaning they don't insulate very well. So they're not very energy efficient. But there is a brand of windows that addresses that does get really good U factors. And the place to find the products that are going to meet all your WUI interface is with a state fire marshal. Their fire engineering investigative divisions, they have the handbook for WUI products. So I recommend you take a look at that for both your commercial and commercial and residential projects. The other thing that's kind of new to the code is there's some requirements now specifically around balanced ventilation with heat or energy recovery. And we're finding that not everyone really knows what balanced ventilation with heat or energy recovery is. So I included this diagram. But this appliance, essentially, this ducted fan system, brings in fresh outside air into the space and has air is exhausting out of your home or your small office, fresh air is coming in, the heat or the energy can be transferred so that the air coming into the home is essentially tempered. So it doesn't come in super cold or it doesn't come in super hot. And some energy efficiency is there. But there's filters and EV or ERV cores that need to be accessed, and these things have to be maintained. So as a result, there's some specific requirements that these appliances are accessible no more than 10 feet above a walking surface, and attic locations require special controls that say, hey, something's wrong, so-called fault indicator display. And then there's also some requirements for the outdoor air intakes themselves, that they're be protected from weather. And then, of course, as a reminder, part of the code is that we have the ability to turn these systems off, and for case of poor outdoor air quality such as wildfire. And the reason we're seeing these balanced ventilation systems come into play on the single family is because as we move more and more towards heat pump space heating, we don't have a good way to bring in outside air. Now, I'll show you an example of what's going on multifamily in just a moment. Part of the code, just FYI, we still have solar required and battery is optional. But the reason I mention this is we have to be battery ready. So there's certain requirements for your sub-panel branch circuits and, space for your future transfer switches for part of the battery storage. But we're seeing folks wanting to add batteries to their project, mostly additions, alterations. And the energy code says, great, you can do it. But it doesn't really tell you much more than that for additions and alterations. So again, it's optional, and a lot of folks are enjoying having those kinds of systems, but you would need to refer to the Title 24 Part 2.5, Chapter 3, to really spell out what is allowable for the battery install and its location and other fireproofing that may be needed if you're putting the battery inside. But these days, most of the battery companies are designing their systems so they can be mounted on exterior walls. And the battery chemistry itself kind of matters. And so as a result, there's been some updates in part 2. And then for this new code cycle, instead, the section that you were going to be referred to is section 330. And part of this is that your aggregate capacity of the battery can't exceed certain amounts of kWh, so kilowatt hour capacity. And now there's a supplemental in 2025 code update that really kind of spells out your maximum aggregate ratings based on a more nuanced take of where it's located. So 3 feet of exterior wall, you can actually bump up to 100 kWh, or exterior walls of dwellings, non-combustible surfaces, you can bump up to 200 kWh, etc. And then whether it's part of detached garage or structures or on the ground and away from things and how far away, that also determines your aggregate. So again, a different part of the code, but thought it was worthwhile to point that out. For multifamily projects, kind of high level, again, updates on the PV and battery BESS, battery energy storage systems, a little bit of updates on the envelope, heat pump, water heater, electric readiness, yes. And kind of the last thing, this outside air ventilation and compartmentalization testing. So that's kind of a new thing for the multifamily. Similar concept, certain climate zones, like climate zones 1, 3 through 5, 11, and 13 through 16, the U factor decrease. So more energy efficient windows are now required. And there is the same exception, like the residential, for the fire hazard severity zones in the wildland urban interface. So again, you're going to want to go to that resource for products that you could use in the WUI zone. There's been a slight, I put this in here, just kind of FYI, some of the exterior insulations using slabs, multifamily projects weren't really appropriate for the job. So now there's code clarification on what standards it needs to meet. And I just put this in here for resource in case that's applicable to one of your projects. The electric ready is, again, for new construction. If you install a gas appliance like a furnace, then you got to make the space heat pump ready. And if you install a water heater that's a gas appliance, then it needs to be a heat pump water heater ready. For cooktops, it can be electric ready in general, any kind of electric, and dryers, any type of electric ready. And then sort of the new kind of code language just spells out that for multifamily projects, when you had individual water heaters, you have to reserve a space that's 39 inches by 39 inches by 96 inches for future heat pump water heater. It's the only place in the code that kind of spells out a size, a reserve size for a heat pump water heater. But I'm finding that if you have that kind of an area for any of your closets for heat pump water heaters, then it's usually big enough to put in everything you need. And then there's some clarification that the electric ready really your electric system has to be designed to meet these potential future loads. So for the central heat pump water heater, this is a new section. So gas water heating is allowed again, but you have to allocate the space for the heat pump water heaters or for the compressor and the tanks. You have to really spell out what the ventilation path and strategy is going to be. You have to provide your condensate drainage, et cetera, make sure all the electricals met. And then these requirements are going to be found in the joint appendices, JA15. For your mechanical IAQ ventilation for multifamily, this part is really new because a lot of the outside air requirements for residential spaces in general, the least expensive way that we've seen in previous code cycles is just to put in a bathroom exhaust fan and have that exhaust fan run 24/7 or have it run intermittently during an hour 24/7. Now, for multifamily housing projects, you either have to do the balanced ventilation or the supply only ventilation. And so that kind of harkens back to that slide I showed you in the single family. In addition to that, you have to have compartmentalization testing by your ECC rater. So otherwise known as a blower door test. And basically what it means is that for new construction, the exhaust only IAQ ventilation fans are no longer an option. So having outside air introduced into the space via balanced ventilation or supply only ventilation is mandatory. But then when you look at the prescriptive method or the prescriptive component package, for climate zones 1, 2, 4, 11 through 14, and 16, which means it's just about like all the climate zones for the CCR REN territory. That prescriptive option is either an energy or heat recovery ventilation balance system. And so with that, there's certain, it's going to be ECC radar field verified. The fault indicator display has to meet JA17, again, referencing those joint appendices or reference appendices. And then there's a couple of sections that I put here that you'll want to refer to. And a lot of times, if you're looking for these systems, you can look for ones that, will often tout that they comply with California Title 24. And we're seeing these. Yeah.
Just to reiterate real quick, so that IQ, the balance supply compartmentalization, every project multifamily will have to do. But the inclusion of this prescriptive requirement means that when you have a modeler trying to trade off stuff, it will be taking a penalty in those climate zones if they don't include an ERV, HRV. The same way previous sections of the code over the years has made it where, hey, it's prescriptive, you can trade it away, but we're running out of stuff to trade away. So it's getting difficult, and in these climate zones, it's going to be more difficult not to do this.
Right. And also in most of our climate zones in the CCR REN territory, except for the ones that are like Monterey, Climate Zone 3 and 5, right there on the coast, all the rest of our climate zones in our CCR REN territory, Climate Zone 4, 12, 13, 14, and 16, you probably want the balanced ventilation with the ERV, HRV anyway, because as this fan is introducing fresh outside air into the space, if it's winter, it's going to be doing a really cold air dump if you didn't have the heat exchange. Or if it's really hot outside, it's going to be dumping just warm air into the house that you're trying to air condition. And at the same time, you're pushing your air conditioned air out. So that's why the heat exchange. And that's kind of why it's a prescriptive part of that prescriptive components for those climate zones. Okay, with that said, oh my gosh, we are almost at time. I'm happy to stay on a little extra. I don't know if Jess is able to, but I can if we need to. But come visit the ccrren.org website to click Energy Code Coach, fill out the form, ask us Code Coach questions. We are happy to do that. I will be making a few edits. I noticed a couple little typos and things as we went through the slides. I'll edit that and get the slide deck over to Jess, and then she will send it out to everybody who attended. And with that, I'm going to hand it back over to Jess so she can update you on a few of the upcoming courses, and then we will see if there's any moments remaining for questions.
Awesome. Thank you so much, Jennifer. That was incredibly informative, and Grant as well for helping out. So up here on the screen, you see our upcoming trainings. Next month, as Jennifer mentioned, the Heat Pumps in Cold Climates course will be running on March 25th. Hot Climates will be lined up for April 21st. And then on May 27th, we've got 2025 Cal Green. We are absolutely interested in hearing from you all about topics that you have of interest. If there was something covered today that you'd love to have more of a deep dive on, please do send us an email. You can reach us at either info@ccrren.org or codes@ccrren.org. And then I have one last request. It is an important part of our funding to gather feedback from the folks who are receiving these trainings. And I just dropped in the chat a link to a 3-question survey. It'll take just a moment to fill it out, but we'd love to know if you found this training beneficial and if you have any other feedback or suggestions for future trainings. And then lastly, just want to promote again that Energy Code Coach service. It is free. You can submit a form online at our website at ccrn.org/codes. And you can also call us. I'll make sure that phone number is listed in the follow-up materials. And we'll be sure to send out the PDF of the slides as well as the recording. And yeah, I'm happy to stay on for a couple more minutes if anyone does want to hop off mute and have any questions answered. And otherwise, just want to say thank you so much for participating. And if any of you will be at the Energy Code ACE conference next week in Irwindale, our team will be participating. We'll have a booth there, so be sure to stop by and say hello. And if you're not yet planning to go, registration is still open and that conference is free. So awesome. Thank you so much.